This video is called Ionic Compound Nomenclature Part 2, and in this one we're going to cover how to write formulas for ionic compounds that contain polyatomic ions. On the common ion list that was downloaded, the document that you downloaded from Aspen or from Teams, the left side of that list has a table of polyatomic ions. Now, what are polyatomic ions? Poly means many, atomic means atoms, so really they're ions made up of many atoms. These are all ions that contain more than one nonmetal atom. Okay, you can see them here. They have more than one atom in them, but they still have a charge, so they are ions. The majority of the polyatomic ions are anions, negatively charged. There is one polyatomic cation that we will be dealing with, and that is ammonium. Basically what this is it's a nitrogen bonded to 4 hydrogens, and that little cluster of atoms bonded together have an overall charge of 1+. Note that the majority of these ions end in either ate or ite for their name. There are a couple of exceptions, but let's talk about the ates and the ites first. Okay. Notice also that anything that ends in ate or ite, they have oxygens. So you know that if you have in the name of your ionic compound, if you see something like chromate, phosphate, nitrite, anything that ends in ate or ite, it's going to be on this list. It's going to be a polyatomic ion. You will not find it on the periodic table. The major exception to that we have to really deal with is hydroxide. It ends in IDE, just as our anions did when we were using the periodic table. However, you won't find hydroxide on the periodic table. There's no element called hydroxygen, which is what that would be if it were an element. So when you see hydroxide or anything that ends in ate or ite, you know you have to refer to this table. As you write these formulas, and I'm going to go over this as we start, I would encourage you to write the formula of the polyatomic ion in parentheses with the charge outside those parentheses. This will help immensely in writing our formulas for our ionic compounds. So let's get to some examples of that. Okay. Sorry. Ionic compounds with polyatomic ions. And just as a reminder, be sure to use parentheses around the polyatomic ion. And I would say always, okay? Always have those parentheses. You need 2 tools. You will need your ionic charges periodic table, because we're still going to be dealing with these metals, possibly the nonmetals. There is that one polyatomic cation. And you're going to need, this will probably be a little small, you're going to need your common ions list. We're looking here for the polyatomic ions, and don't forget about the transition metals that can pop in as well with these Roman numerals. So these are the 2 tools you will need. Okay, let's start with, I actually want to start with iron 3 phosphate. Since the end of that other video, we had just done the Roman numerals with the transition metals. Again, why the 3? The 3 is there because iron does not have a charge above its column. This 3 then represents the charge on that iron. So we know our cation is Fe3+. Phosphate, not phosphide, phosphate. You see the ATE ending? That is a big clue to go look at your common ions list and find phosphate. It's down here. Here's phosphate. This is an ion that has a phosphorus and 4 oxygens all bonded together, and that little cluster of ions, that little cluster of atoms have an overall charge of 3-. So we're going to write that. We're going to take the PO4 and put it in parentheses, and then put the 3- outside the parentheses, which will help us with our formula writing. What you notice is that 3 plus and 3 minus, they cancel each other. So for your formula, you just smush the two symbols together. We have FePO4. No charges are brought over. FePO4, iron 3 phosphate. The reason I'm having you write these in parentheses is to keep these units together because there will be subscripts within the polyatomic ion. Okay, let's look at barium nitrate. Again, nitrate, not nitride, but nitrate. That ATE tells you you're going to be referring to your polyatomic ion list. But first, let's deal with the barium. Barium is in the 2 plus. So our cation is Ba2 plus. Again, nitrate, I know to look at my polyatomic ion list. Nitrate, NO3 with a 1 minus charge. Write the NO3 in parentheses and put the 1 minus outside of the parentheses. Same process as before. These charges do not balance, so you need to crisscross them. This 1 comes over and down next to the Ba. The 2 comes over and down outside the parentheses of the NO3. Again, you're not bringing the charges, you're just bringing the numbers down and over. So our formula is going to be Ba, I only need one of them, NO3 is in parentheses, and then 2 outside the parentheses. Charge on the barium becomes the subscript for the nitrate, and nitrate is NO3. That's why we put it in parentheses. So if I were to draw that out, what that really means is that, I'm going to move this over a little, is that I have one of these, Ba2 plus, and I have 3 of these. I'm sorry, 2 of those. I did that last time too. I got carried away. I have 1 barium at a 2 plus, and I have 2 nitrates, each at a 1 minus. The charges balance out, 2 minus, 2 plus. Okay. Let's look at lithium sulfate. Lithium, need my periodic table. Lithium's in the 1 plus. Li 1 plus. Sulfate, not ide, fate. Boom, it's going to be on this. There it is. SO4 with a 2 minus charge. I'm going to write that in parentheses. Put the charge outside. Okay, 1 plus, 2 minus, don't cancel, going to need to crisscross. The 2 comes down and over by the lithium. The 1 goes down and over by the sulfate. Same process as before. This charge on the sulfate becomes lithium's subscript, and then sulfate subscript is a 1, so I can just write the sulfate in the SO4 in parentheses. Okay, I'm going to keep going with some more examples. I want to do an example with hydroxide. This is the one polyatomic ion that we're using that does end in IDE. Okay, but you want to recognize that as a polyatomic ion, not as an element on the table, periodic table. So let's look at calcium hydroxide. Calcium is in the 2 plus column. So there's my Ca2 plus. Hydroxide is on my polyatomic ion list. It is OH with a 1 minus charge. So again, put that in parentheses, the O and the H, and it has a 1 minus. Those don't cancel. The 1 is going to come down and over by the calcium. The 2 is going to come down and over by the hydroxide outside of the parentheses. So when you write this formula, you have 1 calcium, put the polyatomic ion in parentheses, and then this charge of 2 comes down and over outside the parentheses. So it's really important to keep your parentheses around your polyatomic ion formulas. Okay, I would like to do, well, let's just do aluminum carbonate. Just keep going. We're going to do these last 3 examples together because we didn't really cover this in class. So I want to make sure you have a lot of examples to pull from. Aluminum, 3+. Al3+. Chromate, 8. Got to be on my list here. Chromate, CrO4 with a 2- charge. So I'm going to write CrO4 in parentheses, and it has a 2- charge outside of those parentheses. Charges don't balance. This 2 down and over to the aluminum. This 3 down and over to the chromate outside the parentheses. So in the end, we have Al2 chromate, and I need 3 of those. So Al2, the charge from the chromate, is the subscript for the aluminum. CrO4 parentheses 3. The charge from the aluminum becomes the subscript for that entire polyatomic ion. Oh, I did carbonate. I did chromate, not carbonate. I mixed these 2 up. Whoops. Let's do this. I apologize. I don't really want to start the video over, so we're just going to do this. I apologize for this mix-up. All right. So aluminum carbonate. I'm sorry, aluminum chromate. Now we're going to do copper 2 carbonate. That was my mistake. Copper 2, Roman numeral, because there's no ion charge above the column with copper. So we now know that this is the charge on the copper. Cu1+. And now we'll do carbonate. I apologize again. 8, ATE. There it is, carbonate. CO3 with a 2-. That 8 ending tells us we need to look on our polyatomic ion list. The CO3 goes in parentheses, has a 2- charge. Crisscross. 2 is down and over by the copper. 1 is down and over outside the parentheses of the carbonate. And we get Cu2. We need 2 of those. The charge on the carbonate becomes the subscript on the copper. CO3. Don't need to write the 1. Keep it in parentheses. Again, I apologize for the mix-up. All right, this final one's really important because we have ammonium. We're seeing ammonium and chlorate. This is a compound with 2 polyatomic ions. Ammonium is nowhere on the periodic table. It's got to be here. There it is. Ammonium is that cation, NH4 with a 1+ charge. So we come over here and we write NH4 in parentheses with a 1+ charge. And then I'll get it right this time. Chlorate, there's that ATE ending. We have to look on our table. Chlorate is ClO3 with a minus. This is not an I. This is from chlorine, Cl. Unfortunately, uppercase I's and lowercase L's look the same when you type them. So this is ClO3 with a -1 charge. So we write in parentheses ClO3 with a 1-. These automatically cancel. If they didn't, we would crisscross, but they do. So we just smush the 2 symbols together and we get NH4 with ClO3. You would probably really see this written